Number 5. Notice on number 5 also we have these fractions. We have x over y and we have y over x. If you test this to see that it's homogeneous, you'll see that it is homogeneous. F of tx, ty. It's going to give you tx over ty. Plus ty over tx plus 1. And for both of these fractions, the t's are going to cancel each other out to leave you with x over y plus y over x plus 1. And this again is going to be our function. And when you multiply that by a power of t, it's going to be times t of 0. So because we have both x over y and y over x, we can make either one of our substitutions. Either u equals y over x or v equals x over y. Either one is fine. Let me do this one. V equals x over y. And then multiplying by y and dividing by v, you get y is x divided by v. And when we substitute in for dy dx, we're going to get, here we use the quotient rule. The derivative of the numerator, derivative of x with respect to x is 1, times v, minus the derivative of the denominator, that's going to be dv dx, times x, divided by the denominator squared, divided by v squared. So when I substitute into the equation, my dy dx is going to be that derivative that I just got, v minus dv dx times x over v squared equals x over y, that's my v, plus y over x. Notice that y over x is going to be v to the negative first plus 1. Now here I'm going to start by getting rid of my denominator. I'm going to multiply through by v squared so that this v squared will cancel out from the denominator. That'll leave me with v minus dv dx times x. On the right side, multiplying by v squared gives me v to the third plus v squared no, that's not right. V to the third, v times v squared gives you v to the third. V squared times v to the negative first gives you v, just v to the first. Let me erase that exponent. And then v squared times 1 gives you v squared. We're going to subtract off v from both sides. Those v's will cancel out. So we get negative dv dx times x is equal to v to the third plus v squared. Okay, this is separable. And so to separate our variables, I want my x terms over to the right side. I'll have to multiply by dx over x. My v terms will go over to the left side. So I'll divide by v to the third plus v squared. And that'll give me a negative on the left side. The dx's cancel, the x cancels. I'm going to get 1 over, and this v to the third plus v squared in factored form is v squared times v plus 1 times dv equals, on the right side we get dx over x. And from here we want to integrate. So, because we have fractions, we're going to use partial fraction decomposition. And so on the left side, when I take this fraction, I've got negative 1 over v squared v plus 1. When I set this up as partial fractions, that's going to be equal to a over v plus b over v squared plus c over v plus 1. And I'm going to multiply by the common denominator, which is v squared times v plus 1, so that I get negative 1 on the left side because the denominators cancel. On the right side I get a times, here one of the v's cancel, I'm still left with a v plus 1, okay, and then plus b, both v squareds cancel and I get v plus 1 plus c, and the v plus 1 cancels to leave me with v squared. So this equation simplifies to give me, on this first term I get a v squared plus a. On the second term, distributing, I get b v plus b. And then plus c v squared. So let me combine my like terms. On my v squared terms I have a plus c I only have one v term, bv, and then on my constant terms I have a plus b. So I'll start with my v term. On the left side we don't have a v term, and so I know that b is equal to 0. If b is equal to 0, that leaves me with a constant a, which should be equal to my constant on my left side, negative 1. A is equal to negative 1, and a is equal to negative 1, and I don't have a v squared term on the left side, so c has to be 1 so that these coefficients cancel each other out. C is 1. So let's see, a is negative 1, b is 0, c is 1. Oh, I made a mistake. Okay, let's go fix the mistake. I'm going to change my ink color so that we can fix this. Here, when I distributed by the AV, I get AV squared plus AV. So this should be a V. And then everything else is okay. So when I combine my like terms, I get A plus C V squared. That's okay. When I combine my V terms, I get A plus B times V. Those are my V terms. And then my only constant is B. So these are not correct. Because my constant is just a b, I know that b is -1. If b is -1, and I know that my v terms don't exist on the left side, I know that a has to be 1. 1 minus 1 gives me 0v. So a is 1. And if a is 1, I know that my v squared terms have to cancel out, so c is going to be -1. So a is 1, a is +1, b is -1, c is -1. C is -1. So this left side of my integral becomes 1 over v minus 1 over v squared minus 1 over v plus 1. And then on my right side I just have dx over x. Okay, now let me do my integral up here, and I'll change my ink color again. Okay, so doing my integration. Integrating 1 over v with respect to v gives you natural log of v. Maybe I should have stayed away from green. Integrating 1 over v squared. This is the same as v to the -2nd. You want to increase the exponent. So my exponent becomes v to the -1st, and divide by the new exponent, divided by -1. And here these negatives will cancel. Integrating 1 over v plus 1 gives you a natural log v plus 1. On the right side, integrating 1 over x gives you natural log of x, then plus your constant of integration. So here, just like in problem number 4, you want to bring all your log terms together to maybe cancel them out. So I've got log of v, and I have natural log of v plus 1. I'm going to bring this log of x over. That's going to make it a negative. And then everything else will go on the right side of the equation. That c's already on the right side. And I'm going to bring this v to the -1st over. That's going to make it a negative. On the left side of the equation, you want to combine all these logs together. So I get natural log v over v plus 1 times x equals c minus v to the -1st. If I raise both sides to the power of e, on the left side, e and the natural log cancel, and they leave me with v over v plus 1 times x equals e to the c minus v to the -1st power. And then multiplying by this denominator, I'm going to get the v by itself. I get v is equal to v plus 1 times x e to the c minus v to the negative first. If I replace the v with x over y, I'm going to get x over y equals x over y plus 1 times x e to the c minus, and this will be x over y to the negative first, which will be y over x. And I think that would take a little bit more work to solve for y. I don't know if I could actually solve for y because of the y and the exponential. And so I think I'll leave the answer in this form.